Sometimes, however, you cannot factor a polynomial easily, meaning it's not a difference of two squares. Square roots can then be used. So for instance here, if you have a perfect square, you could say take the square root of both sides, then you have x equals positive or negative 7, because 7 times 7 equals 49, but negative 7 times negative 7 also equals positive 49. Take the square root, take the square root. X equals positive or negative 13. Take the square root, take the square root. Oh no! You can't have a negative under the square root. So there is no solution. That would be as if you had a graph that was opening above or below that never touched the x-axis, because you cannot have a negative under the square root. You can't, nothing times itself will ever be a negative. So always try to isolate the radical before square rooting. For example, I want you to solve the next three by square roots. So for this one, I would add 49, and you have 16x squared equals 49 over 16. Oh, divide by 16 and you get 49 over 16. So x squared equals 49 over 16. Take the square root, take the square root. And this is just like chapter 11. You get 7 over 4 is your answer. Positive or negative 7 over 4. Let's go ahead and do number 2. Subtract 7, subtract 7. X squared equals 0. When you take the square root, your only answer is x equals 0. For number 3, subtract 90, subtract 90. You have negative 3x squared equals negative 90. Divide both sides by negative 3, and you get x squared equals 30. So then when you take the square root, you get x equals plus or minus the square root of 30. When you think of your perfect squares, 4, 16, 25, so on and so forth, 30 is not divisible by any of those, so it's already simplified, so that's just your answer. So sometimes, some quadratic equations can be solved using either method. Other times you have to be smart about which method to use. And that can sometimes be difficult. How do you make the decision which way you should try? So which method would you choose for these equations and why? Or which method would you not choose? So if I'm looking at the first one here, I would first notice that there is no middle value. There is an x squared, but no plain x. When that happens, I'm going to solve for x squared. So I would add 19, and get 288. X squared equals 18. Divide by 288, and get x squared equals 18 over 288. Now this fraction can simplify. You can divide them both by, let's see here. They actually are both divisible by 18. And you get x squared equals 1 over 16. Take the square root, take the square root. X equals positive or negative, because you're solving for x. The square root of 1 is 1. The square root of 16 is 4. For the second one, notice there is a middle term. There is an x squared and an x. When this happens, I factor. So first I need to put it in standard form. So I'm going to add 30x squared. So I get 30x squared plus 75x minus 45 equals 0. I don't know about you, but I think that there's got to be a GCF between 30, 75, and 45. My original thought was 5, but then I thought, okay, that's 6. There's going to be a bigger one. So my GCF My factors of 30 are 1, 10, 3, 15, 30, 5, and 6. So I thought, oh, 15 goes into all of these. So let's divide both the left and the right by 15. So I get 2x squared plus 75 divided by 15 is 5x minus 3 equals 0. I'm going to factor by slide and divide. Slide your 2 over. X squared plus 5x minus 6 equals 0. So what multiplies to be negative 6 and adds to be positive 5? X minus 2 and x minus 3. Since I slid my 2, I divide by 2 to get x minus 1 times 2x minus 3, all equals 0. Last but not least, now I just need to solve my two equations. X minus 1 equals 0, add 1, x equals 1, or 2x minus 3 equals 0, add 3, 2x equals 3, so x equals 2/3. So my final answer is x equals 1 or x equals 2/3. So in general, when there is an x squared but no x, solve for x, then take the square root. When there is an x squared and an x, factor and solve. I would like for you to try solving these ones on your own by factoring, because notice every single one has an x squared and an x. So you factor. Hit pause and then check your answers. All right, number 1, it was a binomial, so you had a GCF of x. So you divided out your GCF and you had x times x minus 4 equals 0. So x equals 0 or x minus 4 equals 0. Either factor, add your 4, x equals 0 or x equals 4. For the second one, what multiplies to be 16 and adds to be 10? Oh, how about x plus 2 and x plus 8? Set each factor. X plus 2 equals 0. X plus 8 equals 0. Subtract 2, x equals negative 2. Subtract 8, x equals negative 8. For the third one, you need to slide and divide. Multiply by 2. X squared plus 6x plus 8 equals 0. What multiplies to be 8 and adds to be 6? Make sure you have your brownie points, x and x, because it's x squared. Oh, how about 4 and 2? So, but don't forget, you can't just start solving now because you slid 2. You divide by 2 to get y equal, or x plus 2 times x plus 1 equals 0. Now I could have done something easier all the way from the beginning. Did anybody notice that in the original, right from the beginning, I could have divided by 2, and I could have had, if I went 2x squared plus 6x plus 4 equals 0, and I said I have a GCF of 2, you'd get x squared plus 3x plus 2 equals 0, which that actually factors to that. So do you see why when you have that GCF, it's so much easier? So now, just solve x plus 2 equals 0. So x equals negative 2. Or x plus 1 equals 0. So x equals negative 1. So that's your answer. So if you can factor out the GCF, factor or divide by your GCF, always and forever. Last but not least, number 4, I hope that you subtracted 10 so that you had it equal 0. X squared minus 3x minus 10 equals 0. Always have it equal 0, factor. What are the factors of x squared? X and x. What multiplies to negative 10 and adds to be negative 3? How about negative 5 times positive 2. Negative 5 plus 2 is negative 3. Negative 5 times 2 is negative 10. So you have x minus 5 equals 0, or x plus 2 equals 0. Add 5, x equals 5, or subtract 2, x equals negative 2. All right, you can go ahead and start on your homework now.